Good evening, students. Let me explain the concept of phototransistor. Phototransistor is a three-layer semiconductor device which has a light-sensitive base region. A lens is used so that the base is exposed to the light. The base senses the light and converts it into the current which flows between the collector and the emitter region. Here the construction of a phototransistor. The construction of phototransistor is nothing but it's similar to the ordinary transistor. In ordinary transistor also N region, P region, N region, then N PNP transistor. If we consider as PNP transistor means P region, N region, P region. Likewise ordinary transistor, but except the base terminal. Here in phototransistor the base terminal is not provided, and instead of the base current, here light energy is taken as the input. Rest of all the things are same as in a normal transistor. The emitter, then collector region, then next the symbol of phototransistor. Here this diagram shows the symbol of phototransistor. Collector terminal, emitter terminal, but here instead of base terminal, here light energy, here one more input, light as input in base region. Then principle of phototransistor. When no light is incident, the small leakage current flows from collector to the emitter called ICEO due to small thermal generation. That is nothing but temperature. If temperature is increased, ICEO value also increased. That is, the ICEO is nothing but it is called as dark current, which is very small. That measurement is 10 to the power of minus 9 amps. ICEO or maximum at 10 to the power of minus 9 amps when base is exposed to light. Here the core concept of a phototransistor. Base is exposed to light. Base current is produced due to generated electron hole pairs. This is photocurrent. Again I repeat, base is exposed to the light. The base current is produced due to the generated electron hole pairs. This is photocurrent. This is denoted as I lambda. So our output current IC is equal to beta into I lambda. The base current I lambda is increases as light intensity also increases, so entirely current also will increases. Here the characteristics of phototransistor. First of all, first diagram shows light when light radiation is, if we increase light radiation, then a base current I lambda also increases. Again if we are linearly, it will increases. Light radiation is increases, I lambda is increases. Output characteristics VCE versus ICE. VCE as x axis, ICE as y axis. Particular stage VCE is increases, but our IC will be constant in a certain stage. But first ICE VCE ratio linearly VCE and LCE increases, but at a certain stage VCE is constant, but IC is constant, VCE is increases. When these are the characteristics of a phototransistor. If the base terminal is brought out, the phototransistor can be used as a normal transistor, that is conventional transistor. Applications in computer logic circuits, it will used in alarm systems also. We will use the phototransistor in level indicators, relays, punch card readers, smoke detectors, etc. And counting machine are also photodiode will be used. This is what about the phototransistor.